Right now, Python developers command some of the highest demand and most competitive base salaries in the tech industry. That economic pull is entirely driven by companies racing to build out their capabilities in AI, machine learning, and data science. But despite the massive popularity of the language, Python is the wrong choice for a huge percentage of new programmers. If your goal is to design front-end websites, build mobile apps, or program high-octane video games, Python will likely fail your expectations. Those specific disciplines rely on other languages. You need JavaScript for the front end, Swift or Kotlin for mobile, and C++ to render games. If you are strictly interested in user interfaces or gaming, you should stop the video now. But if you want to build the logic engines of the future, you are exactly where you need to be. The remaining audience is here for a specific reason: AI, automation, or back-end server development. These fields carry a heavy mathematical and structural burden. They require you to think deeply about complex logic and data flow. When you are trying to learn advanced math, you cannot afford the cognitive load of fighting your own programming syntax at the same time. Mastering AI requires a programming language that acts as an invisible tool. It needs to get out of your way so you can focus entirely on pure logic. Python's primary advantage is its incredibly simple, English-like syntax. Compare this to lower-level languages like C. In C, you have to manually manage computer memory and dictate every hardware interaction. Python abstracts those nitty-gritty details, handling the hardware communications automatically in the background. This abstraction from hardware is exactly what allows a Python developer to dedicate 100% of their brainpower to solving high-level problems. Now that you understand how the tool functions, you have to select a learning path tailored to your own constraints. If you have zero financial budget, free text-based tutorials provide a highly structured, step-by-step foundation. If you struggle with discipline, look for interactive courses. These track your progress and use learning streaks to keep you coding every day. Audio-visual learners should seek out comprehensive video courses or university playlists where they can watch others code in real time. If you are a casual learner, mobile apps are a great way to study during a commute or downtime. However, mobile learning has a limit. Real-world projects ultimately require multiple files, complex directories, and a physical keyboard. There is no single best curriculum. The optimal path is simply the one that ensures you will consistently write code. Here is the non-negotiable rule. Passively watching tutorials is not learning. Only writing code builds the skill. The moment you start typing, you will encounter broken code and red error messages. These errors are not a sign of incompetence. They are the standard diagnostic feedback loop used in all software development. Professional proficiency relies on the ability to read these errors and refine logic, rather than rote memorization of syntax. Installing complex coding environments and local servers can be intimidating when you're just starting out. You can bypass that friction by using free, in-browser online compilers. These web tools require zero installation and prevent all of the usual operating system conflicts. Executing a single line of code in a browser window today is the fastest way to become a developer. Eventually, you will outgrow the browser. This happens the moment you start building complex projects that require multiple interconnected files. At that graduation point, you will be ready to install Python directly onto your computer. Firm. For now, the directive is simple. Stop consuming video content about programming and start actively executing it. The roadmap is defined and the tools are free. Your final task is to close this tab, open a compiler, and begin.